But what if I told you we could actually paint a picture of it? A high-resolution snapshot of every single gravitational...
Well, that's exactly what we're going to do. And here it is. This is it. This is the gravitational landscape. It looks kind of wild, doesn't it? It's complex. It's beautiful. Maybe a little chaotic, but trust me, every peak in every valley in this image tells a fascinating story about cosmic forces at play.
To get there, we have to understand a key idea first. The gravity we feel isn't just...
You know, the best way to think about it is like a giant cosmic tapestry. It's woven from two totally different kinds.
Our Global Geological Situation Report for 2025-2026 reveals critical volcanic activity at Chevoluch and Mayon, while Indonesia faces widespread active threats. In the Mediterranean, Santorini is showing developing activity, requiring close observation. Our comprehensive monitoring network is fully active, with all 45 systems continuously reporting, providing essential real-time data to help us track and analyze these evolving seismic and tectonic dynamics. For Q1 2026, we're tracking 45 continuing eruptions globally and 20 daily active vents, reflecting the persistent influence of the M8.8 Kamchatka trigger event. Critical hotspots include Mayon, at alert level 3 for magmatic activity, Chevoluch, under an aviation code red, and Merapi, experiencing pyroclastic flows. This intensified global activity centers on the Pacific Ring of Fire's magmatic effusion and post-seismic adjustments in the Aegean, all still impacted by the July 2025 Kamchatka earthquake. Examining the Mayon escalation, we observed initial activity on January 1st with alert level 2 and 47 daily rockfalls. By January 6th, the alert was raised to level 3, accompanied by a summit dome collapse and PDC generation. A notable intensification occurred on February 9th, recording 12 major PDCs within a single hour. This rapidly escalated to a sustained eruption by February 13th, characterized by 352 daily rockfalls and the onset of an effusive magmatic phase, demonstrating a critical increase in volcanic activity. Let's review Mayon's sector impact. The 6-kilometer permanent danger zone is critical, with lava flows reaching 3.8 kilometers in Basud Gully east, 1.6 kilometers in Banga Gully southeast, where frequent pyroclastic density currents are noted, and 1.3 kilometers in Miisi Gully south. Our hazard protocols involve a strict no-fly zone for aviation due to plume ingestion risks, and rigorous enforcement of evacuation within the PDZ, ensuring everyone's safety. Focusing on the 2025 magmatic intrusion in Santorini, we observed a significant rebounding dike event where 310 million cubic meters of magma injected into a crustal reservoir 3 to 6 kilometers deep. Notice the marked inflation center near Nia Kameni, revealing a substantial radial uplift of around 150 millimeters annually. While seismicity attenuated by 2026, this magma remains critically poised at depth, serving as a powerful catalyst for potential future activity. Our attention turns to the Aegean's significant threat, the Colombo submarine volcano and its tsunami risk, just 7 kilometers from Santorini. Deep beneath Santorini, a shared magma chamber fuels Colombo through a magmatic plumbing connection, evident from its active hydrothermal venting. The critical concern lies with Colombo's unstable flanks, which present a substantial landslide and tsunami genesis risk. Even moderate earthquakes can trigger these underwater failures, generating destructive waves for the surrounding region. Examining the Kamchatka M.8 megathrust event, we see the seismic activity initiated in July 2025 with an unusually productive foreshock and aftershock sequence, culminating in the main earthquake. This powerful seismic trigger had a significant follow-on effect. By February 2026, Chevoluch volcano entered an explosive sequence, ejecting a plume reaching 11.6 kilometers high. That plume drifted 350 kilometers northwest, leading to aviation codes fluctuating between orange and red due to the ash hazard. We're monitoring high-stakes atmospheric impacts, creating significant aviation denial across the Pacific. Chevoluch's stratospheric injection is currently interdicting vital North America-Asia routes. Further south, Mayon causes localized regional impact in the troposphere, while Dukono and Sangyang Api create low-level disruption, specifically affecting island hopper flights. These diverse atmospheric events demand our proactive analysis and strategic adjustments to maintain safe and efficient air travel in these affected regions. For our regional watch in Indonesia's Sunda Arc, we're monitoring significant volcanic activity. Merapi shows dense gray ash at 5 kilometers with nighttime incandescence. Merapi, at level 3, experienced a southwest dome collapse and pyroclastic flows 1.6 kilometers down Krasak drainage. Semeru reports daily ash events between 300 to 1,000 meters. Lewatobi's eruption has continued since November 2025, and Ibu and Dukono are actively producing daily ash drifting in multiple directions. We maintain high-stakes situational awareness across this critical region. Across the Americas and Pacific, we're observing systemic unrest. Hawaii's Kilauea is at an orange watch, featuring a passive lava lake with magma pressure stable at 1050 meters. In Alaska, Great Sitkin is also orange, showing slow lava effusion building a thick summit flow. Further south, Guatemala's Santa Maria is actively erupting from its Santiaguito dome complex, generating 1 to 4 explosions hourly and block avalanches. These dynamic situations demand our continued vigilance. Our environmental context highlights Solar Cycle 25, nearing its predicted peak between 2024 and 2026, with critical intensity, marked by increased geomagnetic storms and solar flares. We're evaluating a correlation hypothesis, analyzing EPM 2021 planetary theory and ephemeris against global seismic stress modulation through rigorous system analysis. The current status reveals striking coincidental timing of this intensified solar activity with a global seismic crisis. This demands our immediate and high-stakes situational awareness as we further investigate these complex interdependencies. Examining gravitational stress factors along our coastlines, we see critical areas of concern. On the west coast, the Cascadia subduction zone is under extreme tidal stresses, greatly exacerbating rupture risk, warranting an alert red. Similarly, the east coast's continental shelf displays significant tidal strain, pointing to a substantial submarine landslide risk, also at alert red. Our models indicate unprecedented levels of tidal tension, identified specifically within the 2025-2026 window, demanding our immediate attention. Comparing eruption mechanics, System A illustrates an open vent steady state, seen in Mayon, driven by a dynamic balance between fresh magma input and consistent degassing with limited crystal recycling. Conversely, System B, like Santorini, shows a rebounding magmatic dike. This acts as a closed system pressure gauge. A 310 million cubic meter intrusion builds immense pressure, pushing the overlying crust outwards and upwards. Understanding these distinct behaviors is key for volcanic forecasting. Our comprehensive surveillance and monitoring architecture leverages diverse technologies across multiple domains. From space, satellite radar precisely tracks millimeter-scale deformation. On the surface, fiber-optic geodesy provides distributed acoustic sensing for minute dike intrusion detection. In the deep ocean, Centauri observatories deliver real-time geochemistry. Additionally, muography employs cosmic ray muon imaging, successfully demonstrated at Sakurajima, to offer unique subsurface insights. This multi-layered system ensures robust data collection for enhanced geological understanding. Our 2026 geodynamic outlook points to several key areas of concern. We anticipate Mayon will continue its steady state, with a high probability for pyroclastic density currents from dome collapse. Santorini presents a low explosive risk, but a high tsunami threat, urging close monitoring of Colombo slope instability. The Kamchatka Trench maintains elevated seismicity as post-M8.8 adjustments persist. Therefore, our primary directive for the coming year is to enforce strict exclusion zones and maintain real-time monitoring of all submarine assets.
Spread advisory alerts are active for sites including Kilauea, Etna, and Cotopaxi. Critical activity includes Mayon's magmatic eruption and Chevoluch's high-altitude ash plumes impacting aviation.
Watch activity monitors Santorini's 150 millimeters of inflation and Kilauea's increasing summit pressure. Persistent events continue daily across the Sunda Arc and Latin America.
Mayon volcano is currently at alert level 3, escalating toward hazardous magmatic eruption. The timeline notes 346 rockfall events recorded before the January 6 dome collapse. The critical hazard is the pyroclastic density current runout, projected 2 kilometers from the crater via shallow magma extrusion. The Mayon system is dominated by high crystallinity magma, containing 50 vol% phenocrysts, including clustered pyroxenes. This high viscosity drives blocky lava flows and dome instability. The primary hazard results from gravity-driven pyroclastic density currents caused by complex magma mixing.
Our risk mitigation strategy enforced a strict 6-kilometer permanent danger zone, resulting in 0 casualties. Hazard analysis shows specific risks: 3.8-kilometer runout east, 2.0-kilometer PDC emplacement southeast, and 1.3-kilometer lava advance south. Aviation remains restricted due to the ash plume.
We are observing developing unrest in the Santorini volcanic field. The primary concern is the reactivation of the Thera Colombo field, located 25 kilometers northeast of the main caldera. Geophysical data indicates a significant seismic swarm zone for 2025-2026, confirming decades of quiescence have ended.
Geodetic modeling reveals clear repressurization of the shallow magma chamber, located at 3.3 to 6.3 kilometers depth. This intrusion results in a maximum inflation rate of 150 millimeters per year, driven by an estimated volume increase of 12 to 24 million cubic meters annually.
Chevoluch volcano in Kamchatka is maintaining an intermittent code red status, posing significant northern Pacific hazards. The ash plume extends over 350 kilometers to the northwest, reaching cruising altitudes of 10 to 11 kilometers, 36,000 feet. We are also monitoring secondary lava flow effusion at Krasheninnikov. The Sunda Arc exhibits the highest volcanic density globally. Current activity includes Merapi at alert level 2 and Semeru at level 3, with daily eruptions. Level Talik is experiencing Strombolian explosions, requiring a 3-kilometer exclusion, while Dukono maintains continuous emissions drifting eastward. The current Kilauea status is watch/orange, with continuing episodic fountaining observed at the S/SW vents. Mechanically, the diagram confirms a direct hydraulic connection. Pressure transmission from the summit reservoir modulates seismicity in the Upper East Rift Zone. Our conclusion is that we are observing a fully connected, mechanically matured transport system. Central and South American arc activity remains high. Fuego registers 8 to 14 hourly explosions with audible shockwaves, while Santiaguito continues blocky lava extrusion. In Peru, Sabancaya reports up to 37 daily explosions, generating plumes to 2.3 kilometers. This region maintains a persistent Strombolian to Vulcanian baseline. We leverage advanced technologies. Muography images deep conduit density contrasts. Distributed acoustic sensing uses fiber optics for high-resolution dike detection, and INSAR provides global, millimeter-scale surface deformation monitoring via satellite radar. These methods are deployed globally, including at Sakurajima, Iceland, and Santorini. Current SO2 daily fluxes for Kenlon and Eira are approximately 2,600 and 2,200 tons, signaling open vent vigor and shallow magma. These high fluxes cause local air quality degradation and acid rain. However, the emissions remain far below the 15 million ton Pinatubo reference and are below the threshold for global stratospheric cooling effects.
Historical data on Mayon eruptions demonstrates clear progress. While 1814 saw 1,200 deaths, 2026 shows 0 casualties due to real-time monitoring and PDZ enforcement. This successfully shifts the crisis metric from loss of life to economic displacement.
Our Q2 through Q4 watch list identifies 2 critical magma red threats: Mayon, with potential for an explosive Plinian phase, and Chevoluch, posing an aviation disruption risk due to unstable dome growth.
Santorini is at safety orange due to phreatic explosion risk if current inflation continues.
Our Q1 2026 Global Volcanic Situational Report offers a comparative analysis of crustal unrest as of February 14th. We're closely monitoring significant tectono-magmatic interactions globally. The Aegean Sea is experiencing a notable seismic crisis, while southern Luzon in the Philippines shows intensified magmatic effusion. The Kamchatka Peninsula also warrants close attention. These active zones highlight ongoing challenges in hazard assessment and potential population displacement, underscoring our planet's dynamic geology. The Aegean Sea's Santorini-Colombo volcanic field is undergoing a seismic crisis, prompting 11,000 evacuations amid over 30,000 recorded events. Concurrently, the Philippines' Mayon volcano is actively erupting at alert level 3, with 3,749 tons of SO2 emitted daily and 4,000 plus residents displaced. Globally, we're watching Kamchatka's Chevoluch at code orange/red for explosive activity, plus ongoing eruptions from Indonesia's Semeru and Merapi. Stay informed through official channels. We're observing unprecedented radial expansion within the Hellenic Ark's northern caldera, initiating mid-summer 2024. Geodesy reveals a significant inflation rate of 7 millimeters per day, with the modeled intrusion volume exceeding 6 million cubic meters from a source depth of approximately 3.4 kilometers, centered here in the caldera. This deformation pattern, while reminiscent of 2011-2012 unrest, distinctly indicates a more complex fracture event developing. Focusing on Santorini's recent seismicity, we see a concentrated 2025 swarm near Anadros Islet, particularly intense in January and February with multiple magnitude 5 events, one reaching 5.2. This represents a rebounding magmatic dike intrusion, magma physically wedging rock apart along the NESW Kamini line, connecting to the Colombo submarine volcano. Ultimately, this significant seismicity is driven by pulses of magma tunneling far below the seafloor. Our Aegean hazard assessment identifies a critical tsunami potential from the Santorini and Colombo magmatic systems. Their coupling can trigger submarine landslides and fault displacement, generating destructive waves. Historical precedents, like the 1956 Amorgos earthquake, underscore current fears, reignited by seismic swarms. This immediate risk prompted a state of emergency from February to March 2025, leading to school closures and the evacuation of 11,000 personnel and residents. The Mayon volcano is currently at alert level 3, indicating an increased tendency towards a hazardous eruption. We began tracking heightened activity on January 1st with alert level 2, observing elevated seismicity and deformation. By January 6th, magma reached the surface, escalating to alert level 3 with initial dome growth. As of February 13th, effusive magmatic activity continues, characterized by ongoing lava flows and rockfalls, particularly in Bonga Gully. Key visual indicators include a visible crater glow and persistent inflation on the southeastern slopes, confirming slow, degassed magma extrusion. Let's examine the hazard mechanics, focusing on pyroclastic density currents, or PDCs, which are hot mixtures of gas, ash, and rock from dome collapse. On February 10, 2026, we documented 12 major PDC events, with the longest lasting 7 minutes. Observe their reach on the map: 3.8 kilometers towards Basud, 1.6 kilometers to Bonga, and a significant 4 kilometers south into Miisi. This activity correlated with elevated rockfall, peaking at 469 events daily on February 9th. Our civil defense efforts strictly enforced the 6-kilometer permanent danger zone, successfully evacuating over 4,000 individuals to 13 centers. Ashfaro analysis identifies impacted communities including Kamalig, Guinobatan, and Ligao. We've also issued an aviation alert for ash columns exceeding 2 kilometers, advising avoidance of the summit airspace. A state of calamity was declared in Tabaco Albe on January 20, 2026, reflecting the critical ongoing humanitarian response. Let's examine the Kamchatka Peninsula's northern front, focusing on Chevoluch volcano, which is highly active as of February 2026. We're tracking a fluctuating red to orange aviation code, with an ash plume reaching 10 to 12 kilometers, 32,000 to 38,000 feet, and drifting 350 kilometers. This elevated activity is particularly concerning as it's linked to a regional seismicity forecast, indicating a potential M8.8 event. We are closely monitoring the situation, including nearby Bezimiani, for any further developments. Let's review our global activity matrix for selected regions. Indonesia shows high activity. Semeru is alert level 3 with daily eruptions. Merapi alert level 2 with ash plumes to 3 kilometers, and Lewotolak has strombolian activity. The Philippines features Canlaon at alert level 2 with a lahar warning following recent ash emissions, and Taal continuing its explosive effusive status. Finally, Hawaii's Kilauea remains at watch level with a summit eruption in Halema-Uma'u crater. Our surveillance methodology integrates cutting-edge technologies from satellite radar to machine learning. We utilize INSAR, like Sentinel-1A, for millimeter-level ground deformation detection, working in tandem with our GNSS and seismic networks. All this crucial data feeds into our machine learning models, which, for example, identified 25,000 relocated earthquakes in just 2 months in the Greek case. This powerful synthesis provides critical visualization of magmatic plumbing to anticipate surface eruptions.
We're examining 2 distinct modes of volcanic unrest here. On the left, System A, epitomized by Santorini, shows a hidden intrusion where magma forms dikes beneath the surface, leading to tectono-magmatic deformation and earthquake swarms. This activity is often submarine and less visibly obvious. Conversely, System B, represented by Mayon, illustrates an extrusion event. Here, we observe an open-vent stratovolcano actively growing with a visible incandescent dome and generating pyroclastic density currents. These contrasting behaviors require different approaches for effective monitoring and hazard prediction.
Our Q2 2026 forecast focuses on 2 critical areas. Santorini, Colombo faces a high risk of continued swarm seismicity with deflation indicating potential slow slip events. Mayon volcano remains at alert level 3. A sudden SO2 spike and rapid inflation would trigger a hazardous alert level 4 eruption, and seasonal rainfall could cause lahars. Overall, the planetary crust is exhibiting elevated localized stress, making multi-parametric monitoring absolutely vital. To ensure a shared understanding, here are core terms. A PDC is a fast-moving volcanic flow. A magmatic dike is a vertical magma intrusion, and a phreatic eruption is a steam-driven explosion. For monitoring, INSAR provides satellite-based deformation. We'll also discuss strombolian activity, which is mildly explosive with cinder and lava, and earthquake swarms, sequences of quakes lacking a main shock. These definitions are crucial. Seismic events are not isolated. They are ruptures in a continuous, evolving stress field defined by 2 primary factors. We have the internal tectonic engine, where immense friction and stress accumulate at plate asperities. Then there's the external force of tidal acceleration, primarily from the moon and sun, creating varying global stresses. Understanding earthquakes requires appreciating this critical intersection of internal frictional buildup and external gravitational triggers, shaping where and when these ruptures occur.
Observing the Pacific Ring of Fire, we see a century of compelling seismic activity. Beginning with the powerful 1906 Ecuador-Colombia event and the monumental 1960 Valdivia earthquake, megathrust energy appears to migrate sequentially around the basin. This pattern continues through the 1964 Alaska rupture, the devastating 2011 Tohoku disaster, and projects to a significant 2025 event in Kamchatka, illustrating a remarkable migratory release of stress across this volatile region.
The 1960 Valdivia earthquake truly stands as the absolute limit, registering an astounding magnitude 9.5. This cataclysmic event, clearly marked along the Chilean coast, represented the release of centuries of accumulated strain. It fundamentally redefined our understanding of seismic potential, effectively breaking the locking mechanism of the Nazca Plate. We can see its position relative to other significant stress points, like the 2010 Maule quake, highlighting the continuous tectonic activity in this critical region. Here, we visualize the powerful northern shear, revealing a critical pattern of seismic activity across Alaska and the Aleutian Islands. Our hero event, the M9.2 1964 Prince William Sound earthquake, initiated what we now understand as a systematic unzipping of the Aleutian megathrust. Over 6 decades, from the Rat Islands in 1906 to the Alaska Peninsula in 2021, a series of powerful M8+ earthquakes have progressively released stress along this immense fault system.
Here, we visualize the Japan Trench, illustrating the profound concept of recursive stress. Observe the historical seismic activity along this plate boundary, from the 1933 Sanriku and 1946 Shingu quakes to the 1969 Hokkaido Tohooki event. All contributed to the stress buildup, culminating in the monumental 2011 Great Tohoku earthquake, a powerful M9.1 rupture. This event wasn't an anomaly, but a direct consequence of recursive gravitational stress that has been accumulating in this dynamic region for decades. The M9.1 Sumatra Andaman earthquake on December 26, 2004, epitomizes the ocean's wrath, a hero event that triggered a decade of instability along the Sunda Arc. This single megathrust failure unleashed immense stress, directly leading to a significant aftermath sequence. We witnessed major quakes like 2005 Singkil M8.6, 2007 Bengulu M8.4, and 2 M8+Ns in 2012 off West Sumatra and the Wharton Basin. It's a compelling illustration of cascading geological forces.
Let's explore the immense 1952 Kamchatka earthquake, an M9.0 event that struck on November 4th. The map clearly illustrates its vast rupture zone, with the central star marking the epicenter. We also observe a notable precursor, the 1923 M7.2 Milkovo quake. Crucially, surrounding regions still exhibit a significant slip deficit, indicating aspericities were only partially broken. This ongoing stress accumulation truly cements its title as the sleeping giant, highlighting its long-term seismic implications.
This visualization maps a century of seismic stress migration along the Nazca South America plate boundary. From the 1906 Ecuador-Colombia event, watch as activity progressed southward, exemplified by the 1922 Vallenar quake. Later, we see sequences shift, with events like the 2010 Maule and 2015 Illapel earthquakes demonstrating further northward and southward propagation. It truly highlights the dynamic release of strain across this active margin over time.
Here, we explore the Kuril Gap, witnessing a systematic process where seismic events effectively fill voids along this active plate boundary. Observe the progression from major earthquakes in 1958 and 1963 near Kurilsk, followed by events at Shikotan in 1994 and the Kuril Islands in 2006. This culminates with the 2013 deep focus quake in the Sea of Okhotsk, clearly illustrating the ongoing systematic release of accumulated stress across the region. Focusing on the dynamic triple junction between Indonesia and the Philippines, we see the Sunda, Australian, and Philippine sea plates converge. Unlike typical linear subduction zones, this region exhibits complex, multi-directional stress release. This intricate interaction drives significant seismic events, such as the 1918 Malaspang earthquake, the deep 1938 Banda Sea event, and the 1977 Sumba activity, showcasing incredibly diverse tectonic forces. Let's examine these outliers, showcasing how gravitational stress fundamentally drives diverse seismic events. From the 1905 intraplate quake in Bulne, Mongolia, to the massive 1950 Assam-Tibet continental collision, and the profound 2018 deep focus event near Fiji, its reach is global. This clearly illustrates that gravitational stress impacts all plate boundaries, from complex continental collisions in the Himalayas to deep oceanic trenches. affecting locations like Taiwan and Mexico too. We're looking at the projected Kamchatka recurrence event, slated for July 29, 2025. This significant M8.8 earthquake, with an estimated slip of over 9 meters, marks a 73-year recurrence interval. As indicated on the map, this projected rupture zone in red will release the substantial slip deficit accumulated since the 1952 event, effectively closing out that seismic cycle for the region. Here, we explore the hidden rhythm, revealing a compelling correlation between planetary gravitational stress, particularly the Saturn-Neptune cycle, and seismic energy release. Observe how significant events, such as the M9.0 in 1952 and the projected M8.8 around 2025, align with the peaks of this gravitational cycle. This pattern strongly suggests that seismic energy release isn't constant, but rhythmic, consistently clustering within these windows of elevated planetary stress. Our planet's gravitational landscape is anything but static. By rigorously mapping past seismic events, from the historic Valdivia earthquake to those in Kamchatka, we aim to illuminate the critical silence that precedes the next major rupture. This global perspective helps us pinpoint priority monitoring efforts. We're intently focusing on developing asperities like the Aleutian Gap and the Cascadia subduction zone, understanding that these quiet zones hold vital clues to mapping our future seismic risks and improving preparedness. Our 2025-2026 database review highlights a significant convergence event. We're observing solar cycle 25 at its peak, tracking above the 98th percentile. Simultaneously, the geosphere shows validated critical activity, a megathrust in Kamchatka, volcano-tectonic alert at Santorini, and Mayon's eruptive phase, reflecting critical tectonic stress. This correlates with high anthroposphere noise, evidenced by rising anomaly reports, social media mentions, and increased public anxiety. Here's our validation matrix for sorting signal from noise. Instrumental data and historical proxies, from seismic sensors to ancient texts, provide high reliability. Contrast this with statistical correlations, like planetary alignments, which lack proven causality, and perceptual data, like social media reports, requiring biological validation. Our key insight prioritizes physical mechanisms for validating events, such as the M8.8 Kamchatka rupture, with statistical overlaps used solely for predictive modeling. We're monitoring a critical geospheric activation at Santorini, tied to the Jan-March 2025 seismic crisis. The event involves a shallow, non-tectonic magmatic intrusion, specifically a rebounding dike, 3 to 6 kilometers deep, exhibiting over 140 millimeters of inflation. Our spatial clustering data confirms fluid migration is the primary driver, rather than deep stress transfer. This complex feedback mechanism offers vital insights for refining physics-based eruption forecasting, enhancing our understanding of magmatic processes in this dynamic region. We're analyzing the Kamchatka megathrust rupture from July 29, 2025, an M8.8 event driven by stress deficit release within a known seismic gap. Crucially, we observed a significant discrepancy in tsunami predictions. Our models estimated only a 2-meter run-up, yet the actual event delivered a devastating 19 meters. This highlights a critical failure in standard models, severely underestimating the real-world tsunami risk. We are now confirming this as a full geospheric activation.
We're observing the geosphere's simultaneous response to the 2025 global pulse. Santorini exemplifies a closed system, experiencing internal pressurization and swelling without immediate eruption. In contrast, Mayon has entered an open system eruptive phase since December 2025, continuously extruding crystal-rich lava. This dual activation is critical. 2,400 daily visitors are now within Mayon's 8-kilometer danger zone. This confirms a significant and concerning geospheric activation.
Focusing on the heliosphere, the 660 BCE Miyake event, confirmed by tree rings, established our baseline for extreme solar proton intensity.
We're now directly entering solar cycle 25's peak, expected around 2025-2026. Current solar activity already matches our extreme predictive models. Should we experience another Miyake-class event, our GPS and power grids face severe crippling, signaling a critical period of geospheric activation. Let's delve into anomalous observer perceptions within the heliosphere. Subjective reports describe sun simulators, or flickering light, often seen during high luminosity. Our objective analysis points to a visual vestibular interaction, a brainstem response to intense visual stress amplified by atmospheric scattering. This isn't unprecedented. Historical events like Fatima align with a mass physiological reaction to optical stress. Ultimately, we've validated these phenomena as purely biological, not indicative of an artificial construct. Here, we examine the Saturn-Neptune hypothesis. Observe the angular distance between these planets, which hit an inflection point in July 2025. This critical planetary conjunction temporally aligns with a significant spike in global seismic energy, specifically the Kamchatka M8.8 megathrust on July 29th. Our analysis reveals a statistically significant clustering of M greater than or equal to 5.9 events around such inflections. While a strong temporal match, this correlation serves as a powerful time marker for seismic activity, not a force generator, based on available parameters. For Domain C, our hydrometeorological cycle analysis reveals a critical progression of risks. We anticipate high flood potential in 2026, transitioning sharply to significant fire risk by spring 2027, driven by solar cycle 25's maximum preceding a drought window. Increased volatility with East Coast lows will persist through 2029. This solar planetary cycling methodology highlights a vital shift, focusing monitoring from seismic to these evolving hydrometeorological threats. Our 2025 convergence model reveals a critical interplay of global forces. The solar maximum, our primary driver, provides high energy input and magnetic stress, aligning with a key planetary inflection point in July 2025, marked by the Saturn-Neptune conjunction. Together, these celestial influences escalate existing tectonic and magmatic loading, evidenced by critical magma recharge at Santorini and the significant slip deficit in Kamchatka. This established correlation directly points to the compounding conditions leading to the 2025 crisis.
Our strategic outlook for 2026-2029 outlines a comprehensive approach to monitoring and mitigation. We begin by advancing our scientific understanding through the Santorini project, expanding seafloor observatories at Colombo, and implementing real-time geochemical tracking. This foundational data then informs our engineering efforts, enabling a crucial shift to more precise 3D residual slip deficit models, particularly for areas like Kamchatka. Ultimately, robust governance will unify these efforts, establishing global integration by merging INSAR satellite constellations for rapid, open-system volcano monitoring and response.
For our 2026 database summary, we've confirmed Santorini's unrest as purely magmatic, and the 2025 Kamchatka tsunami significantly exceeded far-field models. Solar cycle 25's intensity has also been validated against ancient proton events, and sun simulator anomalies are now explained as physiological responses. We're still monitoring Saturn-Neptune correlations due to their statistical significance, despite lacking a physical mechanism. With these updates, the 2026 database is officially closed, and our monitoring efforts now shift entirely to the 2027 solar terrestrial risk window.
We're examining the February 2026 convergence, forecasting significant geodynamic, heliophysical, and orbital events from January 25th to February 28th. Observe the projected seismic activity on the left, indicating potential vertical acceleration magnitudes. On the right, the critical planetary conjunctions and orbital synergy, particularly the Saturn-Neptune alignment at 0 degrees Aries, are clearly depicted. This convergence merits a red alert status, marking it as a crucial inflection point for global systems.
February 2026 is a critical inflection point where solar cycle 25's declining volatility intersects a new 36-year Saturn-Neptune cycle on the 21st. This configuration elevates the risk of X-class solar flares. We're also monitoring significant terrestrial activity, a high probability of explosive volcanism at Mayon around February 9th, unrest at Santorini, and a 79% chance of M6.0 or greater seismic events in the post-Kamchatka zone, a truly dynamic period demanding our attention. Our cosmic driver, the 0-degree Aries inflection, highlights a pivotal Saturn-Neptune conjunction set for February 21st, 2026. These planetary giants will be just 0.831 degrees apart, aligning precisely at the Aries point, the first degree of the zodiac. Drawing insights from historical cycles in 1882 and 1917, we anticipate that the period of maximum stress or significant shifts will manifest during the subsequent separation phase, particularly between March and July.
We're in the volatile, declining phase of solar cycle 25, which peaked October 2024. The danger is that sunspots entering the low-latitude active zone are statistically more likely to produce powerful, Earth-directed X-class flares. We saw a direct precursor on January 18, 2026, with an X1.9 flare causing a severe S4 radiation storm. Our forecast indicates a high probability of technical blinks, satellite memory upsets, through February 2026. We're examining the significant gravitational stress and tidal deformation influencing our planet. Beginning January 7, 2026, we anticipate alignment amplifications, with the Saturn-Neptune geometry acting as a powerful gravitational pump on the lithosphere by late February. This dynamic, particularly evident in regions highlighted here like South America and Southeast Asia, acts as a crucial final trigger for crustal rupture in an already highly stressed global landscape post-2025.
For Mayon volcano in the Philippines, our forecast for February 9th, 2026 shows a critical situation. We've recorded 47 rockfall events daily since early January, coupled with significant inflation on the southeast slopes. These precursors lead us to predict approximately 12 major pyroclastic density currents within the next hour, with ash dispersion expected westward. Consequently, the alert level is now escalating from 3 to 4, demanding urgent preparedness. Our current target is the Hellenic Arc, focusing on Santorini and Colombo. We're tracking a substantial magmatic intrusion, over 6 million cubic meters, propagating as a 30-kilometer dike between these two volcanoes, an active magmatic breathing process. This mechanism indicates a high risk of tectonic swarms, similar to the 2011-2012 events. Consequently, we're assessing potential submarine landslides within the caldera, which unfortunately carry a significant hazard for tsunami generation. Our focus today is on the Kamchatka megathrust, specifically the aftermath of the M8.8 event observed on July 29, 2025, near Petropavlovsk-Kamchatsky. We anticipate a predicted aftershock zone developing along the Kuril Trench by February 2026. Statistically, there's a 79% probability of M6.0 or greater aftershocks, and a 12% chance of a M7.0 regional event. This heightened seismic activity aligns with the region entering a period of maximum catastrophic potential.
Our global seismic watch list pinpoints active tectonic zones across the planet, particularly highlighting the illuminated Ring of Fire, where plate boundaries show heightened stress. We're closely monitoring the Japan Trench, noting recent M5+ precursors and significant Pacific Plate interface stress. Further, the Sunda Strait in Indonesia is on our radar due to volcanic coupling and a recent M5.4 event. And finally, deep M4.5+ swarms near Tonga and Vanuatu indicate ongoing slab tearing, making these critical areas for our continuous observation.
We are currently tracking a range of atmospheric and perceptual anomalies. Technologically, recent S4 radiation storms stemming from the January 18 X-flare are leading to widespread GPS degradation and system memory upsets. Concurrently, reports of a blinking sun phenomenon are increasing, attributed to solar retinopathy and macula damage, likely exacerbated by flare-induced atmospheric gravity waves. Furthermore, the Australian east coast faces a continued flash flood risk from evolving heat wave and storm cycles. Over the period from January 25th to February 8th, we observed a distinct buildup of geophysical activity. It started with geomagnetic settling and M4.9 precursors on the East Pacific Rise. By February 2nd, deep slab stress and seismic activity near Tonga, Fiji were evident. This rapidly escalated into volcanic activity between February 6th and 8th, leading to a raised Mayon alert level and evacuations in Albay province, marking a clear, interconnected progression. Here's the chronology of our convergence in February 2026. It begins February 9th with the critical Mayon paroxysm, ejecting 12 PDCs and ash to 2 kilometers. The 20th and 21st then bring the 0-degree Aries alignment, an exact Saturn-Neptune conjunction, signaling a maximum geophysical stress window with potential rupture in Kamchatka or Japan. Finally, the separation phase from the 22nd to 28th anticipates peaks in kinetic energy release and significant atmospheric instability. Our strategic monitoring initiatives are wide-ranging. We're activating Santorini seafloor sensors at Colombo and enforcing a 6-kilometer exclusion zone around Mayon due to volcanic activity. In space weather, priorities include hardening satellite memory against S4 storms and monitoring backside coronal mass ejections via solar orbiter. For civil defense, Australia is preparing for flash flooding on the east coast, while globally, we're keenly observing potential geopolitical shifts around Aries Point. We've reached a critical threshold for our planet, where change is not just imminent but precisely orchestrated. February 2026 isn't a random event. It signifies a synchronized release of planetary energy. The intricate geometry of celestial bodies provides the exact timing, while Earth's deep geology furnishes the underlying power, the ammunition for this shift. We are, in essence, witnessing the forceful, fiery emergence of an entirely new 36-year paradigm. Our analytical approach leverages a blend of established research and real-time data feeds. We've incorporated foundational papers detailing the Santorini volcano tectonic sequence, solar cycle 25 heliophysics, and predictions for 2026 catastrophic activity via conjunction correlation. This is complemented by continuous data streams from USGS EMSC for seismic events, the SIDC for solar influences, and the Global Volcanism Program. These diverse inputs, integrated with planetary theory models, construct our robust predictive framework. Let's delve into Earth's gravitational landscape. Our vectorial stress analysis, spanning 1917 to 2026, demonstrates a clear link between the precise alignments of the Sun, Moon, and other planets and significant seismic activity. These celestial configurations create a unique and complex pattern of forces, directly influencing peak stress moments and the overall rupture risk on our planet, as visualized here. We're examining the 1917 Saturn-Neptune conjunction cycle as a critical benchmark. Observe the angular distance minimum in 1917, strikingly similar to our 2026 projection. The comparative vector coordinates for both periods further underscore this recurrence, indicating a renewed specific gravitational torque in 2026, consistent with the 1917 landscape. Historically, these alignments have correlated with significant M8.0 plus seismic WUDES, a pattern we are closely monitoring. While the Moon dominates tidal amplitude, our focus shifts to the extra stress vector originating from Earth. Despite Jupiter's comparatively small individual tidal force, the specific vector alignment of Jupiter, alongside the Saturn-Neptune complex, creates a distinct cross-shear extra stress moment. This unique gravitational signature, notably projected for 2026, represents a combined planetary influence we need to understand thoroughly. Turning to our historical simulation of the 1960 Valdivia earthquake, we observe a critical extra stress index of 9.8 out of 10 for this magnitude 9.5 event. Our vector analysis indicates that a specific planetary alignment, particularly involving the Moon at its extreme perigee and Jupiter, generated maximum crustal torque. This precise alignment coincided with the earthquake's -38-degree latitude, identifying it as the root cause for the extreme rupture risk observed.
Our historical simulation of the 1964 Prince William Sound event reveals a severe stress index of 9.5 out of 10 for that M9.2 occurrence on March 28th. A notable syzygy configuration of Sun, Earth, Moon, Mars likely contributed to a strong gravitational vector convergence on the Aleutian subduction zone, triggering critical asperaries. Interestingly, this peak stress window also correlated with reports of thundersnow and vigorous updrafts in high-latitude zones.
Let's review the 2004 Sumatra Andaman earthquake, a magnitude 9.1 event, which registered a critical 9.7 extra stress index. Precise planetary alignments, like the Moon-Saturn conjunction, were present, leading to vectorial stress overwhelming fault friction through rapid aseismic moment release. This historic event, aligning with a full moon extra stress peak, offers a crucial parallel, directly mirroring the specific vector forces we now project for January 2026, informing our current preparedness.
We're examining a historical simulation of the 2011 Great Tohoku earthquake, a magnitude 9.1 event off Japan's coast on March 11th. Our model shows a critical extra stress index of 9.6 out of 10, accompanied by a precursor increase in magnetic field noise, mirroring observations from the 1989 Loma Prieta quake. This combination of high-stress tidal zone deformation and significant magnetic field disturbances clearly signaled an extreme rupture risk. We validated global gravitational vectors by analyzing major rupture events across the Pacific Ring of Fire and Andean subduction zones from 1906 to 2021. Notice how major earthquakes, like the 9.5 Valdivia event, consistently align with high or extreme extra stress index peaks and specific planetary alignments. This data confirms a cyclic recurrence of rupture windows, underscoring gravitational forces' influence on seismic activity. Here, we're examining a critical precursor sequence for the Kamchatka Peninsula in July 2025, anticipating an 8.8 magnitude event at the Kronotsky asperity. The extra stress index is severe to extreme, resulting from a rupture following an unusual foreshock sequence and aligning with the Saturn-Neptune conjunction. This July 2025 event serves as a crucial geodynamic precursor to the 2026 Aries Point alignment, so monitoring stress transfer to adjacent segments is paramount.
Focusing on the Santorini anomaly in the Hellenic Arc, we're tracking a significant volcano-tectonic correlation for 2024-2025. We've observed distinct caldera inflation and a seismic swarm from January-February 2025, indicative of magmatic degassing. Intriguingly, this unrest correlates with specific Moon-Mars-Venus conjunctions in early 2025. Essentially, gravitational stress is manifesting as heightened magmatic pressure in this region, mirroring subduction zone dynamics seen elsewhere.
Looking at our gravitational forecast for January 2026, we see a crucial Sun-Earth-Moon syzygy, where these bodies are in direct alignment. This configuration, combined with the additional gravitational torque from Jupiter and Saturn, culminates in a primary gravitational maximum. We expect this period of extra stress to be most pronounced over the Pacific Ocean, specifically between January 2nd and 5th. For January 2026, our horizon view reveals critical angular geometry. We're observing exceptionally close approaches, specifically Venus and Mars at a mere 0.185 degrees on January 8th, along with Saturn and Neptune at 0.831 degrees in late February. This tight angular grouping amplifies the resultant vector. with an average altitude calculated at 45.2 degrees within the peak hazard zone. The Aries point conjunction effectively initiates a new high-hazard cycle. This is a crucial period for potential geophysical implications. Our Global Hazard Assessment for Q1 2026 pinpoints peak stress locations, with simulations indicating potential activity around January 4th, plus or minus 1 day. We're closely monitoring Zone A for rupture risk in the North Pacific, Zone B in Chile due to Valdivia correlations, and Zone C near the Santorini anomaly. Notably, vector similarities to events in 1917 and 1960 suggest a significant reactivation of high-latitude subduction zones, demanding our immediate attention.
Our extra stress ledger forecasts critical peak moments: July 2025 in Kamchatka, January 3rd to 5th, 2026 for the Pacific Ring of Fire, and a global event, February 20th to 22nd, 2026. These align with Saturn's approach, syzygy/Jupiter/Saturn torque, and the Saturn-Neptune conjunction. Crucially, the convergence of 1917 and 2026 vectorial coordinates indicates a high probability of extreme rupture risk, statistically correlated with M8.0 events.
Our analysis of Earth's gravitational landscape spanning 1917 to 2026 delves into vectorial stress and seismic correlations. We've compared peak extra stress moments, linking them directly to precise planetary coordinates and rupture risk. Fundamentally, every gravitational effect on Earth stems from the precise positions of the Sun, Moon, and planets. Observe how their specific alignment, like the one depicted, creates a unique and complex pattern of forces impacting our world. We're examining the Saturn-Neptune conjunction cycle, benchmarking against the critical 1917 alignment where their angular distance was a tight 0.629 degrees. Our projections show a powerful recurrence in February 2026, reaching 0.831 degrees. This specific gravitational torque, also reflected in the comparative vector coordinates at the Aries point, notably correlates with historical M8.0 plus seismic windows, suggesting a significant period ahead.
Even though the Moon is our primary tidal driver, we observe a distinct extra stress moment in 2026. This isn't due to Jupiter's raw tidal power, which is minor, but a specific vectorial alignment of Jupiter alongside the Saturn-Neptune complex. This precise 0.831 degree separation creates a significant cross-shear gravitational signature, represented by the diagonal vector, marking a unique event in our planetary mechanics for 2026.
Our historical simulation of the devastating 1960 Valdivia earthquake reveals a critical stress index of 9.8 out of 10 for the M9.5 event on May 22nd. At the rupture point, we observed a unique planetary alignment, specifically an extreme lunar perigee coupled with Jupiter's vector alignment. This precise celestial configuration generated maximum crustal torque at -38 degrees latitude, directly correlating with the earthquake's peak hazard location and resulting in extreme rupture risk. Our historical simulation for the 1964 Prince William Sound event shows a severe 9.510 extra stress index. This was precipitated by a syzygy planetary configuration where gravitational vectors intensely converged on the Aleutian subduction zone, triggering aspericities for the 9.2 magnitude quake. Notably, atmospheric anomalies like thundersnow were reported in high-latitude zones, directly correlating with this peak stress window, underscoring the complex forces at play.
Examining our historical simulation of the 2004 Sumatra Andaman earthquake reveals a magnitude 9.1 event on December 26th. This period registered a critical extra stress index of 9.7, influenced by precise Moon-Saturn and Moon-Jupiter alignments. The rapid aseismic moment release signifies vectorial stress overwhelming fault friction. Critically, this 2004 event's stress peak directly mirrors the vector forces projected for January 2026, providing vital insights for our current analysis.
Our historical simulation of the 2011 Great Tohoku earthquake, a powerful magnitude 9.1 event, highlights critical precursory data. The extra stress index reached a critical 9.6 out of 10, attributed to high-stress tidal zone deformation combined with significant magnetic field disturbances. We detected a precursor increase in magnetic field noise, strikingly similar to observations before the 1989 Loma Prieta quake. This detailed analysis extreme rupture risk that was clearly building.
Here, we validate our gravitational vector model against historical seismic data from 1906 to 2021. Notice the striking correlation between significant planetary alignments and major rupture events across the Pacific Ring of Fire and Andean subduction zones. For example, the 9.5 magnitude Valdivia earthquake occurred during an extreme extra stress index linked to a Jupiter-Moon opposition. Our analysis confirms a distinct cyclical recurrence in these high-stress rupture windows, underscoring the influence of gravitational vectors on these powerful seismic events.
On July 29, 2025, we project a critical 8.8 magnitude event on Russia's Kamchatka Peninsula, centered around the Kronotsky asperity. The stress index is severe to extreme, indicating a significant rupture preceded by an unusual foreshock sequence. This activity coincides with the approaching Saturn-Neptune conjunction. Crucially, this July 2025 event serves as a geodynamic precursor to the 2026 Aries Point alignment, with stress transfer to adjacent segments being a critical factor we are closely monitoring.
Our analysis of the Santorini anomaly for 2024-2025 reveals significant activity in the Hellenic Arc. We're observing magmatic degassing, pronounced caldera inflation, and a recent seismic swarm from January to February 2025. These phenomena correlate with gravitational stress manifesting as magmatic pressure, interestingly aligning with the Moon-Mars-Venus conjunctions predicted for early 2025. This situation mirrors subduction stress observed in the Pacific, highlighting a broader geophysical pattern we need to monitor closely for further developments.
We are reviewing the Mayon volcano hazard profile, classified as a high-hazard cone in the Philippines. This analysis focuses specifically on the 2023 activity cycle and historical lethality data. Based on the latest satellite intelligence, the operational status is currently designated as active. The 2023 activity cycle, spanning 6 months, shows continuous lava effusion alongside intermittent elevated hazards. We observed elevated seismicity, frequent ash plumes, and pyroclastic density currents throughout the period, confirming 4 major risk areas for volcanic activity. The 19th century was a volatile era of recurrence, specifically highlighting Mayon's consistent activity alongside Tal and Balusin. Global records cite recurrent deadly eruptions throughout the late 1800s. Mayon is defined by a consistent frequency of life and property loss, rather than a singular event. The 1814 catastrophe was the deadliest historic eruption, causing over 1,000 estimated fatalities. This major pulse event utilized lahars and pyroclastic currents. The high casualty count resulted from these lahars burying populated settlements, clearly establishing the volcano's capacity for severe mass casualty events.
The 1897 major phase case study confirms the hazard cycle, occurring 83 years after the 1814 catastrophe. This weeks-long eruptive episode resulted in an estimated 350 to 400 fatalities, validating the persistent risk to the dense populations surrounding the cone. The threat involves 2 primary mechanisms. Pyroclastic flows are density currents of hot gas and rock, observed in both 1814 and 2023. Mechanism B is lahars, volcanic mudflows, which caused over 1,000 deaths in 1814. This combination classifies Mayon as a high-hazard cone. Our comparative risk matrix shows Mayon parallels Vesuvius in generating catastrophic pyroclastic flows and lahars. Grouped with Tal and Balusin, it is part of an extremely active regional cluster. The primary risk factors are explosive capability, dense populations, and the high frequency of events.
The Mayon hazard profile shows an active status with confirmed lava flows expected through September 2023. Historically, the volcano has been lethal, documented by mass casualty events. The current perspective is high risk due to the intersection of explosive capability and surrounding population density.
Our forensic simulation reconstructs the 1960 Valdivia earthquake, a 9.5 magnitude event serving as our peak hazard benchmark. Occurring on May 22nd in Chile, this great Chilean earthquake, centered 35 kilometers deep, registered an extra stress index of 10.0, the absolute maximum. This unprecedented rupture coincided with a rare planetary alignment. Jupiter and Saturn's gravitational pull orthogonally intensified the Moon's tidal force, generating maximum crustal torsion and facilitating Earth's largest recorded seismic event.
Let's examine our forensic simulation of the 1964 Great Alaska Earthquake, a magnitude 9.2 event near Prince William Sound. We observed an extreme stress index of 9.8, primarily driven by high-latitude gravitational focusing. The alignment of the lunar node with the solar vector created a pronounced spring tide effect on the solid Earth crust. This historical event offers crucial insights, sharing a tectonic setting similar to our Kamchatka 2026 forecast, highlighting the subduction zone's sensitivity to gravitational fluctuations.
Our forensic simulation of the 2011 Tohoku earthquake reveals a critical supermoon correlation. This magnitude 9.1 event, occurring on March 11, 2011 in the Japan Trench, registered a severe 9.6 stress index. A key anomaly was its timing, just days before a supermoon, significantly amplifying tidal forces. The complex interplay between the Moon's pull and the Jupiter-Mars planetary vector created a distinct trigger spike a full 48 hours prior to the rupture.
Our forensic simulation of the 1952 Kamchatka earthquake reveals a critical recurrence interval anomaly. This magnitude 9.0 Severo-Kurilsk event, occurring at a severe 9.7 stress index, is a direct gravitational ancestor to our 2026 predictions. The planetary alignment, then, suggests the 2026 landscape is a geometric echo of 1952, pointing to a high probability of another M9+ event occurring in the same coordinate zone.
Analyzing the 2004 Sumatra earthquake, a M9.1 event, our forensic simulation reveals an extra stress index of 9.9, marking it as severe. This peak hazard was driven by an unusual equatorial vector alignment. We found a full moon alignment, a gravitational anomaly in the Indian Ocean, and vector forces perfectly coinciding with the Sunda megathrust. These factors, alongside equatorial bulges, significantly increased rupture risk, particularly during solstice Ms, underscoring the complex planetary geometry at play.
Here, we're correlating the 1917 seismic curve with a projected 2026 vector path. Observe how major ruptures from 1917, like Avezzano, Kermetic, and Samoa, align perfectly with peaks in the extra stress index as the Saturn-Neptune angle widened. This historical pattern suggests that if 2026 follows a similar trajectory, the highest risk period for significant seismic events will extend from the January minima through the spring separation phase. We're examining significant statistical correlations revealing atmospheric and volcanic resonance. Past major eruptions, like Lassen Peak in 1917, coincided with extreme cold, polar vortices, and mid-latitude thundersnow events. This pattern, and eruptions clustering near planetary minima, leads to our 2026 forecast. We see a high probability of another major eruption next year, perhaps at Chevoluch or Santorini, suggesting similar jet stream disruptions and thundersnow events are likely. While the Moon and Sun are the primary drivers of Earth's tidal amplitude, an often overlooked extra stress comes from distant planetary alignments. Even though planets like Jupiter and Venus exert minimal individual tidal forces, their specific orthogonal alignment can generate a crucial shearing force. This subtle yet powerful force is capable of overcoming the friction holding geological faults, potentially triggering lithospheric failure. It highlights how broader cosmic mechanics influence our planet's stability.
Let's look at our U.S. coastal strain analysis. The West Coast is experiencing extreme tidal stresses along the Cascadia subduction zone, heightening the risk of rupture and tsunamis. On the East Coast, we're seeing significant tidal strain concentrated on the continental shelf, which poses a clear risk of submarine landslides. Crucially, both coasts are showing unprecedented levels of tidal tension, particularly within the upcoming 2026 window.
In 1917, amidst the deafening roar of artillery in trenches like these and the collapse of empires, something else entirely was happening far above. From July 28th to August 5th, the cosmos reached a silent mathematical zero point, the Saturn-Neptune conjunction. This precise celestial alignment, occurring on August 1st, presented a stark contrast to the earthly chaos, a hidden moment of cosmic order within humanity's storm.
Let's define the precise window for this significant 1917 event. We observe the angular distance between the bodies narrowed dramatically, reaching its apex on August 1st, 1917. The minimum separation was a sharp 0.629 degrees, occurring in Leo. Importantly, this was a singular sharp pass, unlike other cycles' triple conjunctions. The planetary gears locked with maximum intensity just once before separating, highlighting its unique nature. Let's examine the approach leading to the Passchendaele offensive July 28 to 31st, 1917. On the 28th, an astronomical window opened as Saturn and Neptune tightened, coinciding with a rare Atlantic lull. This period of quiet allowed Allied forces in Flanders to finalize their preparations on July 29th. The tension broke on July 31st as the Battle of Passchendaele began, a major offensive launching into the mud, a stark manifestation of Earth mixing with water. From August 1st to 5th, 1917, we observed a remarkable geometrical lock, an exact astronomical conjunction, the zero point of the year, with less than a degree of separation in Leo. This cosmic apex occurred amidst striking earthly contrasts, a quiet Atlantic with no active storms, yet the third anniversary of World War I saw the conflict enter its brutal fourth year. Concurrently, Russian unrest intensified under the Kerensky government, bridging the volatile gap between revolutions, a truly pivotal alignment of circumstances. The 1917 hurricane season, despite its overall activity, featured a profound meteorological void. Following Hurricane 1's dissipation on July 14th, the Atlantic experienced a distinct silent window from July 28th to August 5th. The atmosphere truly seemed to hold its breath during this lull, before tropical violence resumed with Hurricane 2 developing on August 6th. This highlights how even active seasons can have unexpected, quiet intervals between significant storm events.
We're exploring the powerful archetype of structural dissolution. This era witnessed the collapse of traditional power as the Romanov dynasty fell and monarchies across Europe began to shake. Simultaneously, the horrors of Passchendaele transformed battlefields into dissolving mud, signifying a profound dissolution of both land and men. An invisible agent, the Spanish flu, was quietly eroding global boundaries and human vitality, illustrating a deep breakdown across political, physical, and biological structures. These echoes of the cycle reveal global dissolution events linked to specific alignments. In 1846, Aquarius saw Neptune's discovery, revealing invisible mathematical structures. The 1917 Leo alignment brought the Russian Revolution and World War I, dissolving empires and physical bodies. Later, 1952's Libra coincided with the Kamchatka quake and Great Smog, dissolving shorelines and air quality. Finally, 1989's Capricorn marked the Berlin Wall's fall, dissolving concrete structures and ending the Cold War. Examining these singular geometries, we see a clear distinction. The 1989 Triple Pass illustrates a prolonged dissolution, depicting a gradual triple-phased erosion over many months. Contrastingly, the 1917 Single Pass represents a sudden, direct shock.
This abrupt alignment was specifically triggered by the Sun-Saturn conjunction on July 27th, culminating in the main event on August 1st, a much sharper immediate impact than the extended retrograde pattern of 1989. We've honed the 1917 Neptune-Saturn conjunction date to August 1st using precise orbital data rather than the often cited August 10th. This precise zero point allows us to explore a critical 4-day window. We highlight the remarkable absence of tropical storms in the Atlantic, our negative data, which sharply contrasts with intense war efforts occurring simultaneously in Flanders. Our methodology relies on comprehensive data from NOAA, NASA planetary ephemerides, and historical geopolitical logs.
Let's explore a true pivot point, the week of July 28 to August 5, 1917. This period saw a rare celestial alignment, mirroring profound terrestrial chaos. As the Atlantic held a quiet meteorological lull, the very structures of the 19th century, its empires, monarchies, and tactics, were irreversibly dissolving in the mud of Flanders and the streets of Petrograd. It was a geometrical lock in the heavens, met by a global dissolution on Earth.
Let's explore Earth's gravitational landscape, where every terrestrial effect is a direct result of the precise positions of the Sun, Moon, and planets. Our analysis, spanning 1917 to 2026, correlates these celestial alignments with peak extra stress moments and rupture risk. Observe this specific planetary configuration. Its unique alignment creates a complex pattern of forces, illustrating the profound cosmic interplay driving these terrestrial phenomena.
Our analysis centers on the Saturn-Neptune conjunction cycle, benchmarking against the significant minimum observed in 1917. We're projecting a powerful recurrence of this angular distance minimum in 2026. The 1917 conjunction in Leo established a specific gravitational torque, and our comparative vector coordinates for 2026 reveal a similar dynamic at the Aries point. This recurrence strongly correlates with historical M8.0+ seismic windows, indicating a critical period ahead.
Our analysis of vectorial mechanics reveals a fascinating extra stress moment anticipated in 2026, stemming from the Moon-Jupiter opposition. Although the Moon remains the primary tidal influence, registering 1 compared to Jupiter's significantly smaller 0.000052, it's the specific 0.831 degree alignment of Jupiter with the Saturn-Neptune complex that generates this unique cross-shear. This planetary configuration creates a distinct gravitational signature, warranting our close attention.
Here, we're examining a historical simulation of the 1960 Valdivia earthquake, a powerful 9.5 magnitude event. Our analysis reveals a critical extra stress index of 9.8 out of 10. This was driven by a precise planetary alignment, notably involving the Moon and Jupiter, which generated maximum crustal torque at the -38-degree latitude. The conjunction of extreme lunar perigee and this specific Jupiter vector alignment precisely matched the peak hazard location, indicating an extreme rupture risk. Our historical simulation details the 1964 Prince William Sound event, a magnitude 9.2 occurrence, showing a severe 9.5 out of 10 stress index. This coincided with a rare syzygy planetary alignment of Sun, Earth, Moon, and Mars. Gravitational vectors converged intensely on the Aleutian subduction zone, triggering asperities. Intriguingly, thundersnow was also reported in high-latitude zones concurrently, suggesting a fascinating environmental correlation during this peak stress window.
Examining our historical simulation of the 2004 Sumatra-Andaman magnitude 9.1 event, we identified a critical extra stress index of 9.7 out of 10. This period, marked by specific planetary alignments like the Moon-Saturn conjunction, saw rapid aseismic moment release as vectorial stress overwhelmed fault friction. Crucially, the extra stress peak observed during this 2004 event directly mirrors the precise vector forces we are now projecting for January 2026, offering vital context for our ongoing assessments. Examining our historical simulation of the 2011 Great Tohoku earthquake, a magnitude 9.1 event, we recorded a critical extra stress index of 9.6 out of 10. Intriguingly, a precursor increase in magnetic field noise was detected, mirroring observations from the 1989 Loma Prieta earthquake. The analysis points to high-stress tidal zone deformation, combined with these magnetic field disturbances, as key indicators signaling the extreme rupture risk. This simulation provides vital data for understanding predictive patterns.
Our global validation from 1906 to 2021 uncovers a significant pattern. You'll observe key rupture events highlighted across the Pacific Ring of Fire and Andean subduction zones. The data table details these major quakes, revealing a consistent high or extreme extra stress index correlating with specific planetary and lunar alignments. This compelling evidence suggests a direct link between these gravitational vectors and major seismic activity, confirming a cyclic recurrence of rupture windows.
Our analysis projects a critical precursor event for July 2025 on the Kamchatka Peninsula, with an anticipated magnitude 8.8 rupture at the Kronotsky asperity. The extra stress index is extreme, driven by unusual foreshock activity and coinciding with the Saturn-Neptune conjunction. This event is a vital geodynamic indicator, transferring significant stress to adjacent segments and setting the stage for the 2026 Aries Point alignment. Close monitoring is essential.
We're seeing a significant volcano-tectonic anomaly developing around Santorini and the Colombo Field, which our analysis forecasts for 2024-2025. We're tracking critical phenomena, including substantial caldera inflation and a predicted seismic swarm from January to February next year. Our vector correlation indicates this unrest aligns with specific Moon-Mars-Venus conjunctions, suggesting gravitational stress is translating into heightened magmatic pressure in the Hellenic Arc, paralleling subduction stress patterns observed in the Pacific. This situation demands close monitoring.
Here's our forecast for the January 2026 gravitational landscape. We see a significant Sun-Earth-Moon syzygy, where these three bodies align. This alignment, coupled with the Jupiter-Saturn torque, will generate a primary gravitational maximum, particularly concentrated over the Pacific Ocean. This creates a peak extra stress window we'll be closely monitoring, running from January 2nd to 5th, 2026. Examining the angular geometry for January 2026, we identify two critical closest approaches: Venus-Mars at 0.185 degrees on January 8th and Saturn-Neptune at 0.831 degrees on February 21st. This tight planetary grouping significantly amplifies the resultant vector. Notably, the Aries Point conjunction, occurring with an average altitude of 45.2 degrees within the peak hazard zone, is projected to initiate a new high-hazard seismic cycle. Our global hazard assessment for Q1 2026 highlights several critical peak stress locations. We've identified a significant rupture risk in Zone A, a notable Valdivia correlation in Zone B off South America, and what we're calling the Santorini anomaly in Zone C. Simulations pinpoint these peak hazards to January 4th, 2026, with a one-day margin. Importantly, vector similarities to historical events in 1917 and 1960 strongly suggest a potential reactivation of high-latitude subduction zones.
Our extra stress ledger pinpoints critical gravitational peaks, a July 2025 precursor in Kamchatka, then early January 2026 for the Pacific Ring of Fire, driven by planetary torque, and a global event in late February 2026 from the Saturn-Neptune conjunction. The convergence of specific vectorial coordinates indicates a high probability of extreme rupture risk, statistically correlated with M8.0 events.
Welcome to our exploration of the gravitational landscape, where we delve into a comprehensive temporal and spatial.
Welcome to The Flicker and the Pulse, an exploration tracing anomalies across immense scales. From the energetic solar flares, representing the flicker in the stratospheric reaches, to the subtle pulses we detect deep beneath the seafloor, our investigation connects these seemingly disparate events.
we conduct a comparative analysis of macro-scale shifts, integrating insights from social anecdotes, historical radiocarbon spikes, and cutting-edge distributed acoustic sensing to reveal profound underlying connections.
Imagine experiencing something utterly impossible, a momentary disruption of reality itself. People across the globe reported what they called the glitch in the sky. One described it as pitch black for a split second, like a light bulb dying, while another felt the entire universe momentarily phasing out of existence. Others simply stated, the whole world blinked. These first-hand accounts from the same day paint a picture of a shared, unsettling phenomenon, hinting at something beyond our current understanding.
Let's delve into a fascinating historical precedent, the miracle of the sun at Fatima, Portugal, on October 13, 1917. Some 70,000 witnesses described the sun as a dull silver disk that appeared to dance and change colors. Remarkably, rain-soaked ground and clothes reportedly dried instantly. This profound event, occurring during the high global tension of World War I, also parallels later phenomena like Giaye and Medjugorje. It's a striking example of collective human experience.
Our biology significantly filters how we perceive cosmic phenomena. The retina is vulnerable to damage, causing afterimages, and our perception is easily tricked by effects like Gustav Fechner's, where prolonged staring alters perceived colors. Even atmospheric density fluctuations can mimic cosmic dimming. Clearly, the human eye is an unreliable sensor for accurate cosmic events, underscoring our critical need for more objective and advanced tools.
Let's delve into the profound 36-year cosmic rhythm between Saturn and Neptune, which beautifully illustrates how societal structure and dissolution interact. This cyclical dance, where the steady forces of structure, Saturn, meet the transformative energy of dissolution, Neptune, embodies an ancient archetype that correlates with significant terrestrial upheaval. As we follow this powerful pattern, notice the marker for February 2026, indicating our next crucial juncture where these energies are set to converge, suggesting another period of deep societal transformation is on the horizon.
We're exploring dissolution through diverse case studies. Consider the explosive eruption of Krakatoa in 1883, where solid land dramatically dissolved into the atmosphere, reshaping the very geography. Then fast forward to 1989, witnessing the symbolic dissolution of a political structure as the Berlin Wall crumbled. Finally, in 1991, Mount Pinatubo's eruption demonstrated another form, a climate-altering dissolution that significantly impacted our global environment. These events, though vastly different, powerfully illustrate how structures, whether physical or political, can dissolve. The trees actually remember profound cosmic events, captured as Miyake events. These are sharp, global, single-year spikes in radiocarbon, confirmed from Arctic to Antarctic, indicating powerful cosmic ray bursts. Notice dates like 774 CE, an event in order of magnitude larger than Carrington. This shifts our understanding, moving from subjective historical accounts to objective chemical scarring, etched into nature's own timeline for us to discover. We're decoding a significant carbon-14 spike, which appears to originate from a powerful cosmic event, likely a solar superflare, directly impacting Earth's atmosphere. Our Python box models then trace this carbon-14 as it rapidly disperses throughout the biosphere and oceans, leaving a distinct chemical signature. This pattern points to a global physical bombardment, with solar superflares being the most likely culprit, though gamma ray bursts or magnetars are also possibilities. Examining this profound timeline, we observe the consistent rhythm of the 11-year solar cycle, depicted by the white wave. Overlaying these are the red bars, marking significant Miyake events. What's truly intriguing is their irregular timing. While there's an undeniable cosmic pulse, these intense cosmic ray bursts don't strictly align with solar maxima or minima. Notice the 5410 BCE event near a solar minimum, and 774 CE occurring 2 years before a maximum. This highlights a chaotic element within the universe's rhythm, challenging purely regular predictions. Looking at the Santorini crisis in 2025, we're monitoring an early earthquake swarm occurring just 7 kilometers northeast of Santorini, near the highly threatening submarine volcano Colombo. The immediate concern is the potential evacuation of thousands if this activity escalates. Our critical task is to precisely distinguish whether this seismic swarm is purely tectonic or if it represents a more ominous magmatic foreshock signaling an imminent eruption. Distributed acoustic sensing, or DAS, truly allows us to listen with light. Our sensor is a simple 45-kilometer dark fiber optic cable, often deployed on the seabed, as depicted here. We transmit laser pulses down the cable and measure the backscatter interference to detect minute strains caused by acoustic vibrations. This ingenious method effectively transforms one physical cable into thousands of virtual sensors, offering incredibly detailed, real-time insights across vast distances. We're truly facing a data flood, as this illustration highlights the sheer volume of information coming in. Our capability has dramatically improved, doubling the detection rate compared to traditional land seismometers. However, the challenge lies in this massive volume. The raw data quality often isn't sufficient for automated workflows. This creates a critical connection. While the machine reliably records the event, much like the Fatima witnesses, it's still the human element that must interpret and extract the true meaning from this rich data. We're comparing anomaly detection across 3 scales. The eye captures subjective, localized events with high sensitivity but low reliability. The tree highlights global, historical anomalies, like Miyake events, highly reliable annually despite lower immediate sensitivity. And the fiber offers extreme, real-time sensitivity for microstrains, with moderate reliability, though processing heavy. These illustrate diverse approaches to understanding unusual phenomena.
So, is what we're encountering truly a glitch or a critical warning sign? There's a widespread intuition of a fundamental shift in reality, a sense that existing structures are dissolving. This isn't purely subjective. Our data points to concrete evidence like radiation spikes and increased magmatic unrest. As brilliantly put, we are acutely sensitive to environmental changes. This perceived glitch might actually be our intuitive grasp of a deeper physical reality that we haven't yet fully understood or mastered.
We're shifting our focus from ancient superstitions to advanced sensing. Whether we're analyzing a 1,000-year solar storm from 774 CE or anticipating a submarine volcanic awakening in 2025, our survival fundamentally depends on the speed of our perception. This critical insight drives us to constantly refine our tools, truly hear the pulse of our world, and proactively prepare for upcoming events.